Welcome friends. So today we are going to take a class on the complex number second part, which we will be doing and completing the chapter of the complex numbers. So for that we will be discussing the last part of the complex number, that is the polar representation. So before that, I hope that you have seen the complex number part 1 video, and if you have understood that also, and if you are having any problem, please, I would suggest you see the video once more or twice. That would make the things quite easy to you. Okay, and if you have not yet subscribed to my channel, please subscribe it for getting all the new notifications which will be coming, because I will be going on uploading one by one chapter of maths and physics of class 11 and 12. So let's start today the continuation of the complex number, that is, we will be today dealing with the polar representation of complex number. Polar representation of the complex number. This is our topic today, and with this we will be ending the complex number. So what is polar representation of complex number? For example, if a complex number is written as a plus ib, so how to represent it in the polar form? The polar form representation is r cos theta plus I sin theta. This is the polar representation of a complex number, r cos theta plus I sin theta. So what is r? Here r is root over a square plus b square. This is how you find the value of r, and the tan alpha will be b by mod of b by a. Tan alpha will be mod of b by a. Now we know that if this is our axis, then this is 0, then it is pi by 2, then it is pi, it is 3 pi by 2, and this is 2 pi. So here we will take both a and b will be positive. Here a will be negative and b will be positive. Here a will be negative and b will be negative. And here a will be positive and b will be negative. So in this case, the theta will be represented as alpha. Here theta will be represented as pi minus alpha. Here theta will be represented as alpha minus pi. And here theta will be represented as minus of alpha. Okay, so these things we have to keep in mind, and next I will show you how to represent the polar representation of the complex number. So for example, we'll take up an example and see. So let us see how we represent the polar form of a complex number. For example, if the complex number is given half plus root 3 by 2i, half plus root 3 by 2i, so first of all, I'll find my r. R will be root over a square plus b square. So this square and this square. So r is coming, this is 1 by 4 and this is 3 by 4, which is 4 by 4. So r is coming 1. This is the r. Next I will show you how to find the tan alpha. So tan alpha was b by a. So this is root 3 by 2 by half, which is coming root 3. So tan alpha is coming root 3, and here alpha will be tan inverse root 3. So in that case, alpha will be written as pi by 3. We all know that if tan alpha is root 3, we know the angle of alpha will be pi by 3. So now let us see, I told you that here my A is plus half and B is plus root 3 by 2. So both are plus, so they belong in the first quadrant I showed you, and in the first quadrant theta will be alpha. So here theta will be equal to pi by 3. So my polar representation was what? R cos theta plus I sin theta. That means it becomes 1 cos pi by 3 plus I sin pi by 3. So this is the polar representation of this complex number. Okay. So let us take few more examples in this. So you will be able to understand how we are doing it. Let us see few more examples of the polar representation of the complex number. So if I take, suppose if I take half minus root 3 by 2i. So again, r will be root over half square plus minus root 3 square, and r is coming out to be 1 by 4 plus 3 by 4. So it's coming as 1. Similarly, tan alpha, which was b by a, will come out to be minus root 3 by 2 by half, and we know in a mod we don't take the minus, so it is root 3. So alpha is coming pi by 3. Now friends, note my a is plus half and b is minus root 3 by 2. So a is plus and b is minus. That means it is in which quadrant? It is in the fourth quadrant. It is in the fourth quadrant. So in the fourth quadrant, what do we say? Theta is minus of alpha. That means my theta will be minus pi by 3. So my representation will be r, which was cos theta plus I sin theta, will now be written as r is here 1. So it is cos minus pi by 3 plus I sin minus pi by 3, and we know cos minus theta is cos theta and sin minus theta is minus sin theta. So this is our polar representation of the complex number. Okay. So one more example we'll take and finish it up. The polar representation. We'll take one more example. So let's see, by taking another example. Suppose I take minus 1 plus 1 by root 3i. So here r will be root over minus 1 square plus 1 by root 3 square. So which is coming out to be, r will be 1 and 1 by 3. This is coming 1 plus 1 by 3, which will be 4 by 3, and that will be 2 by root 3. That is r. Similarly, my tan alpha, if I want to find my tan alpha, so my tan alpha, which we know is b by a. So we can write it as, it is 1 by root 3 by minus 1. So tan alpha is coming 1 by root 3, and for which alpha will be pi by 6. Next, my a is minus 1 and b is 1 by root 3. So a is plus, a is minus and b is plus. That means it is in which quadrant? A minus B plus. It is in the second quadrant. It is in the second quadrant. So in the second quadrant, what do we know? We know theta is equal to pi minus alpha. So theta will be pi minus pi by 6. So theta will be 5 pi by 6. So what will be my polar representation? It is r cos theta plus I sin theta. So what is the value of r? 2 by root 3 cos 5 pi by 6 plus I sin 5 pi by 6. So this is my polar representation, and this is how we represent a complex number into its the polar form. So this is what we have learned today. So that is all, friends, and I hope that you will be, if you go through these once or twice or thrice, this video if you see 2 or 3 times, I think the things will be very clear to you. So I would suggest you to please keep watching this, and also keep a notification that my further classes will be coming, so you can get the help from those also regarding physics and maths. So hope you have understood. Thanks a lot. Okay.